Alright, in this video I'm going to be talking about a very interesting topic, and that is correlation and regression actually. So in this video I'm going to focus more on correlation, and subsequent videos will be looking at regression. So stay tuned and please do well to follow and subscribe to follow this series. Now, when we talk about correlation, the truth of the matter is it's a very popular word, even in English language. We say it is an everyday term. We say something is correlated, two things are not correlated, or they are correlated. There's no correlation between these things. What does it mean actually? Correlation simply means relationship or association. There's two things which are said to be correlated, two things which are correlated simply means association or relationship. So if something is correlated with each other, there's a relationship between them, and that's it. So I'm going to start with this correlation, and then I'm going to talk about formulas and the types of correlation, the formulas, and how to go about it generally. So correlation is all about relationship or association between two things or more generally. So if two things are correlated, it means there's a relationship between them, or there's an association between them. There's a pattern between them. Now, data. Because correlation is actually under the branch of mathematics or called statistics, that is with data. So we're going to be talking about data. I think you already know what data are generally. Data are in mathematics are sets of numbers or values. So data can be univariate data, and data can be bivariate data. So the univariate data, one variable being observed relative to a particular thing, and a bivariate data, two variables observed simultaneously in relation to a particular thing. So we have two things in a bivariate data simultaneously looking at it at the same time. So that's a univariate data and a bivariate data. So now we move on to the types of correlation. So the types of correlation that we have, the very first one, we have the positive correlation. Now the positive correlation, you have two variables. Don't forget, in this correlation, we are using the bivariate set of data. That's, we are comparing two things now. So we are using two variables being observed. So the relationship between y and x, now looking at this, an increase in x brings about an increase in y. That's it. So meaning that if someone does well in perhaps mathematics as a subject, if there's a positive correlation between maths and physics, if he does well in maths, there's a tendency that he's going to do well in physics. That's the meaning of positive correlation. Increase in one brings about an increase in the other. And the diagram is like this. This diagram is called a scatter diagram, actually. A scatter diagram. And we want to draw a line for it. It's called the regression line, which we are going to look at much later in subsequent videos, regression. But for now, we're just focusing on correlation. Now, so that's positive correlation. The second one is negative correlation. An increase in x brings about a decrease in y. That is, as one quantity is going up, the other quantity is going down. Now, this positive and negative correlation, in order for you to understand it better, I can perhaps use something like the Boyle's law. If you're watching this and you're a science student, you understand that in chemistry, you have the Boyle's law and then the Charles law. The Boyle's law states that if you have something like this, as the volume is getting bigger, the pressure, if you have this is the Boyle's law. Meaning that as the volume is getting bigger, the pressure is getting smaller. As the volume is getting smaller, the pressure is getting bigger. So that's a typical example of the, this is for this typical example of the negative correlation. One quantity brings about a reduction in the other quantity. The Boyle's law can be explained is similar to the negative correlation, while the Charles law, which is also in the gas law, as the volume is decreasing, the temperature is also decreasing. So if you're a science student, you can understand it. If you're not a science student, I still think you can understand it. So this negative correlation, increase in one quantity is becoming bigger and the other quantity is actually becoming smaller. But in the positive correlation, one quantity is leading to an increase in another quantity. Both quantities are becoming bigger. So the negative correlation, the diagram, the scatter diagram, it has a downward slope like this. Unlike the positive correlation that has the upward slope, the negative correlation has the downward slope. Now, so that's the negative correlation. Now, the third type of correlation is the zero correlation. In this one, there's no relationship between X and Y. X and Y are not correlated at all. No relationship, no association between X and Y, and that's it. So these are the types of correlation that we have. The next one now would be to go to the calculation and the example, looking at questions under the correlation and looking for the correlation coefficient. Alright, the correlation coefficient now. This is a statistical measure that determines the amount of linear relationship between two things. In this case, X and Y. It's called the coefficient of correlation. So, of course, we have already established that correlation is an association or relationship between two things. We are comparing X and Y, two variables. Don't forget that we are looking at bivariate set of data. So the bivariate set of data, like I explained earlier, talks about two sets of data, two things now. Now, the linear relationship, in case you don't understand what that means, linear means in mathematics a straight line. The graph of anything, if it gives you a straight line, if you draw a graph and it gives you a straight line, that is a linear graph. For instance, if you have something like this, 2x plus 3y is equals to 5, an equation like this, and then you draw this graph, you have this, and it gives you this, or like this. As far as it's a straight line, this is a linear graph. So, but when you have a graph and then you draw it like this, and then you have a curve like this, it's no longer linear. This is a quadratic graph. So, a linear relationship is straight line. And if you look at this is a straight line. This line is called the regression line. And like I said, we're going to look at regression in the subsequent videos. So, now, the correlation coefficient is between -1 to 1. Very important. It falls within the range of -1 to +1. So, when R is close to +1, it means the two values are highly positive correlated. Now, for instance, if I get the relationship between X and Y and I have it at 0.85, now 0.85 is very close to 1. So it means that X and Y are highly positive correlated. Now, but if R is close to -1, it's highly negative correlated. If, for instance, I have something like this, -0.2, now is very close to, -0.9. This is very close to -1. So it means X and Y are negatively correlated. And then if R is close to 0, there's low correlation between the two variables. So now the next thing, now we'll look at the example questions properly, to look at questions and how to solve the correlation. Now, there are two methods of solving the correlation. So now, going back to this, the method of solving correlation. So there are two methods generally of the correlation. solving the correlation, we have the Pearson coefficient of correlation or the product moment correlation, and then we have the Spearman rank correlation. Now, this Pearson coefficient of correlation is a parametric method of solving correlation. That's why I put it in brackets using another font, because I want you to understand this parametric mode and then non-parametric method of solving. Now, the parametric method of solving or parametric statistics, they use precise measurement. They use they make assumptions about the set of data. They use precise measurement like formulas, mean, standard deviations, and the rest of it like that. Why the non-parametric do not make assumption is just a rough estimate, and then in the sense that, and they rank. So, but the parametric and the non-parametric is not really our focus for now. So we're going to be using I'm going to show you how to use the Pearson coefficient of correlation to solve, and then I'm going to show you how to use the Spearman rank correlation to solve the question under correlation. So we take the very first one, the Pearson correlation. Okay, now this is an example, and we want to use the Pearson product moment of correlation. Don't forget that I mentioned the two methods of solving. We have the Pearson product and the Spearman rank correlation. So now the Pearson product, I have two sets of data. Don't forget that this is a bivariate data, and then we are making use of two sets of data. We are comparing two things. So the quantitative test and verbal test, for example, want to know their correlation. So based on the formula for Pearson product, that's why I asked it. And I'm going to write the formula right now. So the coefficient of correlation, K, is n summation xy minus summation x summation y over square root of n summation x squared minus summation x squared square root of summation y squared minus summation y squared into bracket. Now, don't be so perplexed. It's not a complicated formula. So this is the formula, and I'm going to use it right here now. So my next column, I have xy. Now, so xy based on this formula now is going to be x times y. So I multiply 6 multiplied by 5, that is 30. 8 multiplied by 6, that is 48. 4 multiplied by 3, that is 12. 7 multiplied by 5, that is 35, and 3 multiplied by 3, that is 9. So x squared means that I square this. Now my x is quantitative test. So 6 squared is 36, 8 squared is 64, 4 squared is 16, 7 squared is 49, and 3 squared is 9. Now my y squared is my verbal test y. So 5 squared is 25, 6 squared is 36, 3 squared is 9, 5 squared is 25, and 3 squared is 9. So once I have this, I have my xy, x squared, y squared. Now I'm going to find the addition. That is what this sign is. This thing that looks like E is actually called sigma. It means sigma, which means summation. So if you are a science student, in science, especially in physics, we use a lot of notations like alpha, beta, gamma, and the rest of that. So this is simply summation. So I'm going to add all of this together. Now when I'm going to add my x, summation of x, y. By the time I do that, 30 plus 40 gives me 70 plus 12, 90 plus this gives me 125 plus 9. Now gives me 134. Now I'm going to also add my x squared together. This plus this gives me 100 plus this 16, and 116 other plus 58. So 116 plus 58 gives me 174. Now I add my y squared together. This gives me 61, 70, 95, 1. So So when I input the values, I have all of this. So 670 minus 616 over this. Doing the calculation, this gives me 24 over the square root of this, and then it gives me my answer 0.97. Now this 0.97, what does it mean? Now don't forget, earlier in the video I told you that the correlation coefficient is between the range of -1 to between -1 to 1, and the more the value gets to 1, it means the stronger the correlation. So this 0.97, since it's very close to 1, it means our conclusion or our comment for this is that they are highly positive correlated. Now they're highly positive correlated. The truth of the matter is this: they are highly positive correlated. So it means that there is a strong relationship or association between the test in X and the test in Y. That's the quantitative test and the verbal test. Now, I want to say something that you should know, very important. Why doing this? It is very important not to mix it up. Putting it in the formula, summation xy is 134, summation x is 28 and this. Don't mix. Summation of xy is different from when you are putting in the formula says over square root of summation x squared minus this. Now summation x squared and is different from summation x into bracket or square. Summation x squared is the addition of all the values of x, which gives 28. But summation, sorry, I never value that. Yes, summation x squared is this for this. 28 is addition of solution x, that's squared. But this one means I first of all have to square this particular one, this x. I square it. When I square their values, then I add all of them together. Then it gives me solution x squared. So don't mix it up. Solution y squared, the same thing. It means that this is y. So it means that I first of all square y and then add everything together. That's what solution y squared is. Different from adding everything of y and now squaring it. So you don't want to mix it up. It's very, very important. So to take note of that. So all you need to do when you have a question like this, finding correlation, you just need to increase the value using the Pearson product moment of correlation. That's the parametric method. Is this formula, and you do this, and then you have it. So they are highly positive correlated, meaning that there is a strong relationship between x and y. So the next thing we need to look at an example on the next kind of correlation, which is the Spearman rank correlation. So okay, so the next method or the second method is to use the Spearman rank correlation, which I said. Now, the Spearman rank correlation, I said earlier, is a non-parametric method of solving correlation. But in this Spearman, there's something that we first of all do. If you see a question, now math score and physics score, see the set of scores among a particular set of students. Now 53 in math, 38, 61, 86, and 28. In physics, 48, the same student scored 48, 36, 67, 47, and 58. Now to do to solve correlation using the Spearman method, you can't just go straight like that. There's something you need to do, and what's that? You need to rank them first of all. So my math score, I call it x, and my physics score, I call it y. Now using the tabular form in column is I write them out. Now my Rx is the ranking of the score, the mathematics score. So I rank them in order from the highest to the lowest value. So the highest value is 86, so 1, then followed by 61, that's 2, then 53, then 38, 4, and 28, 5. The same thing, I do the same thing for y. So the first value is 67, which is 1. Now the second value is 53, third value 48, 47, the fourth value, and 36. Value. Now, that is it. So you have to rank them first of all, in most cases from highest to lowest value. Now after ranking them, I have my Rx and my Ry. Now I subtract the ranking of the x and the y together. So I have 3 minus 3 which is 0, 4 minus 5 which is minus 1, 2 minus 1 which is 1, 1 minus 4 which is minus 3, and 5 minus 2 which is what? 3. So I square it, that's the next column. So 0 square is 0, minus 1 square is 1, 1 square is 1, 3 square is 9, and 3 square is also 9. So I'm going to find the summation at. Now, the summation of all of these, 1 plus 1, 2, plus 9, 11, plus 9, 20. That's the summation of d squared. So when I have that now, summation of d squared is 20. So my formula for the sperm calculation is 1 minus 6 summation d squared by n into n squared minus 1. So it becomes 1 minus 6 times the summation of the d squared. Don't forget that d is the subtraction of the ranking after you have ranked both sets of data. So 6 times 20 over n. N is how many values? I have 5 values. Now into 5 squared minus 1. So this is 1 minus 6 times this 120 over 5 into 25 minus 1. So this is 1 minus 120 over 120, which is 1 minus 1, which is 0. So I have this. What this is telling me, I'm having 0. What this is telling me that there is 0 correlation between x and y. Now this is very weird because there's hardly any time whereby you will get 0 correlation. Take note that these data are just random. I picked them off the top of my head. So it is not the data that was formulated anyway. I just picked them. So at random it gave me 0. But in most cases, when you're solving a standardized question, you will most likely not be getting 0. That does not mean that you can't get 0, but most cases you will not get 0. But now I have 0, it means that there is no correlation or there is no relationship between mass score and physics score. So this is it on Pearson product and Spearman, the two methods of solving correlation, the parametric method and then the non-parametric method. Now there's something very important that I must not fail to mention, which is the fact that correlation, let me write it properly, correlation does not imply causation. Now, if you are watching this, you probably have heard of this phrase before. Correlation does not imply causation, maybe in English. Now, but this phrase is actually, or this sentence is actually a statistical term that is being used. Correlation does not imply causation, meaning that just because two things are related or there's a relationship between them does not imply that one thing causes the other. Just because there's a pattern between two things does not mean that one implies the other. For example, in the first example that we looked at, the Pearson product, our correlation was 0.97. There's a strong relationship between that math and physics. Now, or quantitative and rather. So, now, it does not imply that, it does not mean that because there's a relationship, does not mean that you scoring high in math, meaning that you score well in physics. Although it can happen, but does not mean. Now, for example, let me give a layman example. Having money and good health are positive correlated, or yes, they are highly correlated. Now, because money and good health are positively correlated, there's a relationship between them, between having money and having good health. Now, this does not imply that money causes good health. There are other factors that may be responsible for good health apart from money, which you agree with me? That is exercise, eating healthy, which does not necessarily have to do with you having money. Is it not true? Yes. So if you say having money and having good health, it means that anybody who has money automatically has good health. But we know that is not true. Anyway, so money and good health are correlated, but does not imply that money causes one to have good health. That is a simple explanation for this particular phase, that correlation does not imply causation. It's important to understand this so as not to, in analyzing data, so as not to analyze data wrongly. It can lead to, it can lead to multiple effects. Imagine analyzing data for companies, so and then you just assume this. It is very, very wrong. So this is all on correlation as far as this video is concerned. So in subsequent videos, we'll be looking at the other part, regression and fitting lines of regression and best line of fit and all of that. So if you enjoy this video, do well to like, subscribe and turn on notification so that you can get more videos like this and other videos that I will be putting along as far as mathematics and statistics is concerned. See you in the next video. Bye.